Okay, class, I had a few students ask for a review of how to simplify exponents. So we're going to review the rules of exponents. I'm going to take a kind of different approach than I did in my initial video when I taught this. So hopefully this will help you kind of wrap your head around it. So first of all, the main thing about simplifying exponents is that you have to know what simplify means. The first thing, now the order of these things doesn't matter, but to be simplified, an exponent, you can have no negative exponents. You should also see each base only once, and you can have no powers to powers. Okay, so to be simplified, all three of these things have to be true. Well, these problems can range from super simple to very difficult. So let's go through some examples. And of course, we want to remember that anything to the 0 power is 1. So if I had like -3 to the 0 power plus a to the 0 power, we'd say, well, what does this expression equal? Well, this is 3 to the 0 power because this negative does not belong to this exponent. Remember, the exponents only belong to whatever they're closest to. So 3 to the 0 power is 1, but we're looking at the opposite of that. Then we're going to say plus a to the 0 power. Well, a to the 0 power is 1. -1 plus 1 is 0. So the value of this expression would be 0. Okay, so remember that anything to the 0 power is 1. But how would this have been different if it had said -3 to the 0 power plus a to the 0 power? Well, -3 to the 0 power is 1, not -1, because this entire thing to the 0 power is 1 plus 1. This would have given me 2. So the difference is whether or not the sign is included in the 0 power. Well, it's included if it's in parentheses, but it's not if it's not. Okay, so that is the 0 power rule. Now, negative exponents, I could have something as simple as simplify z to the -9. We're like, well, the problem with this, there's only one thing there, but the problem with it is that it's negative. Well, to make it positive, we need to put it downstairs. Okay, or I could have something like 3 over x to the -4th. And the only issue with this expression is that this exponent right here is negative. But to make it positive, I'm going to put it upstairs. So I already have a 3 up there, and I'll just have x to the 4th. Well, what becomes positive is only the exponent, and it takes with it its base. And in this case, its base is x, so x is going to go upstairs. So that's what these rules say. These negative exponent rules say if you have a negative exponent and it's upstairs, put it downstairs. It'll be positive. If you have a negative exponent downstairs, put it upstairs. It'll be positive. Okay, these can get a little more complicated. So let's say though that I have a -5xy to the -2. Well, how do I simplify this one? And I see a negative here and I see a negative here, but remember, these are rules of exponents and they only apply to the exponents, and the only thing that I need to be positive are the exponents. So I need this exponent right here to be positive. Other than that, this expression is just fine. Well, this exponent belongs to the y and to the y only because this isn't all in parentheses. So it only belongs to whatever it's closest to. So this -5x is the value -5x. I don't need to make this positive because it's not, and it's not an exponent. But to make this y, the -2 positive, I need to put it downstairs. When I do that, this exponent becomes positive, and this is now a simplified expression. Okay, some other things that you might see then is you might see something like a to the 3rd, b to the -5, c to the -2, something like this. And a cubed is positive. This exponent is positive, so this exponent is grand. It's just dandy and fine. But this exponent, no bueno. It is bad, and it needs to go downstairs. When it goes downstairs, the exponent becomes positive, not the base. The exponent does. Okay, and this one would be c squared downstairs. Okay, what if I had a constant, kind of like this one, but I have a, let's say, -3, I don't know, x, and we're going to say this is to the -4. Well, this exponent is naughty, so it needs to go downstairs, and it takes its base with it. Well, what is its base? In this case, everything in these parentheses is its base. So when it goes downstairs, I'm going to get a -3x. The entire thing is the base, but now the exponent is positive. I just took this expression, put the exponent and its base downstairs, and made the exponent positive. That means there's a 1 up here. But this is not considered simplified still, and it's not because this is negative, but it's because I have a power to a power. So let's go talk about how I would simplify powers to powers. So hold this thought right here, and we will go through each of these. I'm going to write this problem right up here so we come back to it. But first, I want to talk about how we would deal with each base occurring only once. Now, if I have the same base, if I have w to the 5th, and I want to times this by w cubed, well, literally w to the 5th means w times w times w times w times w. Okay, and w cubed means 1, 2, 3 of these related through multiplication. Well, this is also related through multiplication, so I literally have 1, 2, 3, 4, 5, 6, 7, 8 of these related through multiplication. And that shows you or proves that when you're multiplying bases, so this is when you see a base more than once. If you see the base more than once, the relationship of the exponents, if they're being multiplied, if the base that you're seeing is being multiplied together, then you add those exponents. So this is the same thing as w to the 5 plus 3. Okay. Another thing that could happen is you could see these top to bottom. So maybe you're going to see p to the 2nd, and that's going to be over p to the 6th, say. Well, again, I can see this base twice, so I need each base to occur only once, but I see it twice. So I'm going to use this rule right here, this quotient rule, to simplify these. So this rule says that the relationship of these is subtraction. Great. And it's always going to be the top minus the bottom, because in subtraction the order matters. Well, that means then that I get p to the -4th. And because we just barely did the negative exponent thing, I know that if I have this negative p to the -4, to make the -4 positive, I'm going to put it downstairs. Okay, but you could also say that p squared over p to the 6th is the same thing as p times p. And there's 1, 2, 3, 4, 5, 6 of these related through multiplication. Well, anything divided by itself is 1. So I'm going to leave behind a factor of 1 here. You can see that this one is this, and 1, 2, 3, 4 p's are being multiplied together. So this is indeed the answer, regardless of whether you factor them out or you use the rule. This is the answer that you'll get. So when the exponent is greater in the denominator, then the power will end in the denominator. When it's greater in the numerator, then it will end in the numerator. What does that look like? Well, let's say that I have q to the 6th over q to the 4th. Well, 6 is bigger than 4, but if I literally do q 6 minus 4, then I get q squared. Well, I don't need to stick this downstairs because it's positive, so I just am going to get q squared. And you can see that there's 1, 2, 3, 4, 5, 6 of these q's upstairs, and 1, 2, 3, 4 downstairs. These will all cancel, and you can see that those two q's are right here, still needing to be written in exponent form. Okay, so this is making sure that each base occurs only once. So let's do a combination now of negative exponents and each base occurring only once. Okay, so let's say I've got m to the 3rd, n to the -5, and p 7th. Now let's make a 2 here, and an 8, and m to the 6th. Let's make that a -6. N to the -2, and p to the 4th. Okay, so this has a combination of negative exponents, and I see bases more than once. So I can decide which order I'm going to do this in. I can combine bases first, or I can make positive exponents first. But I need to go through each term and make a positive, and make sure that it's positive and the base occurs only once. So I'm gonna go through and make each exponent positive to start out with. So I've still got this 2 up here, and you should also note that simplify, if we're talking about a fraction, always, this goes without saying, which is why it's not listed here in the rules of exponents, that the constants need to be simplified. So let's go ahead and simplify those. 2/8 is the same thing as a 1/4. This m cubed, it is positive. So right now I'm just going to focus on negative exponents, and I'm going to say, I'm going to get rid of all the negative exponents. So I'm going to m cubed, this n to the -5th, he's going to have to go downstairs because he's being naughty. P to the 7th is positive, so it can stay upstairs. Now I'm going to go downstairs and say, hey, this m to the -6 is being naughty, so it needs to go upstairs. Again, when I move them upstairs or downstairs, their exponent becomes positive and they move with their base. N to the -2 is being naughty, so it's got to go upstairs. And p to the 4th is just fine, so it is going to stay downstairs. Okay, so now that I've gotten rid of all the negative exponents, this isn't considered simplified. I still need to make sure that each base occurs only once. Well, some of these are related through multiplication, and some of them are related through division. So which ones are related through multiplication? Well, all this is related through multiplication, but the only bases that I'm trying to combine here are these m's if I'm looking on top. If I have 3 m's right here and 6 m's right here, then I'm going to get m to the 9th on top. I'm also going to say, oh, I don't need this one, so I'm just going to get rid of it, but I'm going to put the 4 down here. Okay, so my m's, I see this base once now only, and I used this rule right here, this product rule, and combine the exponents by adding them. 3 plus 6 is 9. Now I'm going to go to my p's. Well, I've got some p's upstairs and some p's downstairs. So I could do p to the 7 minus 4 and get p cubed, which is great. So I've got p cubed. Or I could say, hey, there are 3 more p's upstairs than there are downstairs. So they are 3 more of them here. Okay, now I see the p's only once. There aren't p's upstairs and downstairs, so we're good there. So I've checked off the m's and the p's. Now let's go to the n's. Well, I've got 2 n's upstairs and 5 downstairs, which will give me n to the -3. But to make it positive, I would have to put it downstairs. So the n cubed is going to go downstairs. If you look at this, you can see that there's 2 n's upstairs and 5 downstairs, which means there are 3 more downstairs. Now I see each base only one time. I've gotten rid of all the negative exponents, and this is the simplified version of what we started with here. Okay, so now let's talk about powers to powers. Well, when we're talking about powers to powers, all we want to do is get rid of the powers. So this could be something as simple as, well, what is x to the 8th squared? Well, this literally means I have this twice. X to the 8th times x to the 8th. And remember that when we're multiplying bases, we add the exponents. So let's see then if we can skip this middle step. Let's go from here to here and say, I don't want to expand this. I just want to know how to get from here to here. Well, 8 and 2 are related how to make this 16? Well, they are related through multiplication. So if I'm raising a power to a power, this is called the power rule. If I'm raising a power to the power, then I multiply their exponents. So this is literally x to the 8 times 2, which is 16. Okay, the same thing is true if it's downstairs. It doesn't matter where it is. If I have, y to the 4th and I want to raise this to the 5th power, then I'm going to have y to the 20th power. All right, so 4 times 5 is 20. And I could have stuff upstairs and downstairs, so I can have different things upstairs and downstairs. So say like I have a to the 7th over b to the 3rd. These are different bases, right? So I can't combine their exponents. So I see these bases only one time, but they're all being raised, say, to the 3rd. Well, that means that I have this 3 different times, but I don't want to expand it. That's bad juju, right? I want to just use the rule, and the rule says that the exponent just belongs to each one of those. So the relationship of these exponents is multiplication. So 7 times 3 is a to the 21st. 3 times 3 is b to the 9th. So I see each base only once. There's no powers to powers, and there's no negative exponents. Okay, well, let's keep going here with some different other examples. So what if I had c to the negative 5 over d to the 8th, and I wanted to raise this to the 3rd power? Well, I can get rid of the negative exponent first by putting the c downstairs, or I could get rid of the power first. I'm just going to do the power first because I can. It doesn't matter which order you do these steps, but make sure you do this systematically so you don't get all confused. But first I'm just going to say, okay, I don't want any powers to powers, so I'm going to do c to the negative 5 times 3, which is c to the negative 15. And I'm going to do d to the 8 times 3, which is d to the 24th. Okay, so there's no powers to powers. Check. That one's done. But I have a negative exponent. Well, to make this positive, I need to put it downstairs. So what is my final answer going to be here? It's going to be 1 over c to the 15th d to the 24th. And that is going to be simplified. Okay, so now let's go back to this one that we were doing before. This negative 3x to the negative 4. Again, we could do this multiple different ways, but to make this exponent positive, I'm going to put it and its entire base, which happens to be the negative 3x, downstairs. Now I want to point out that if I had negative 3x to the negative 4, this would be different, because now this says 1 over, there's a negative here, 3x to the 4th. And if I have negative 3x to the negative 4, this is also different. This says negative 3 over x to the 4th, because what the exponent belongs to matters. In this case, this is the entire base, so its whole base goes with it. In this case, only the 3x is its base, so that goes with it. In this case, only the x is its base. Okay, so hopefully this clarifies a bunch of the questions that you had, but let's we digress. Let's get back to this problem here. How do we get it all the way done? Well, now that I'm raising all this to the 4th power, negative 3 to the 4th power is just negative 3 times negative 3 times negative 3 times negative 3. So that's going to be 3 times 3 is 9 times 3 is 27 times 3 is 81. So, and it's going to be positive because there are 4 negatives. So I'm going to get 1 over 81. And then x to the 4th, remember, this is x to the 1st power, so 1 times 4 is 4. The relationship of these exponents, because it's a power being raised to a power, is multiplication. So I'm going to get x to the 4th. Okay, so this is if you have a product inside and it's being raised to the power. That 4 belongs to both the negative 3 and it belongs to the x. Well, we already expanded that one and we explained how we got this. So product to a power, I need to get rid of that power. I have 4 of everything inside of here. Well, what if I have whole combinations of powers and negatives and all of that? So let's do maybe 1 or 2 more. So say like I've got 2x cubed y to the negative 2. All of these are being raised to the negative 3, and I'm going to write that over 5x to the negative 2 y. Okay, well, how would I simplify this? There's all sorts of things wrong here. I see x's twice, I see y's twice, I see powers being raised to powers, and I see negative exponents. But I have to deal with this in some kind of order, so I'm just going to get rid of this power to power first. So I'm going to say, hey, just look at only the top here. Well, this is a negative exponent, so I could just distribute the negative exponent and say, this is 2 to the negative 3, x to the negative 9, y to the 6th, because the relationship of these exponents is multiplication. Okay, now that I've gotten rid of that power to power, now I can combine bases. Or maybe I want to get rid of exponents first. So let's get rid of negative exponents first. Well, to get this 2 to the negative 3 to be positive, he's going to have to go downstairs. So that's going to be 2 cubed. To get this x to the negative 9th positive, he's going to have to go downstairs. And to get this y to the 6th positive, it's just going to stay right where it's at. This 5, it can just stay right where it's at. And this x to the negative 2, it's being naughty, so she's going to have to go upstairs. And this y is great, right where it's at, so it's going to stay downstairs. Okay, so now I got rid of all the negative exponents. Well, I still have not simplified it because I see x's and y's twice. So now let's get rid of my x's and y's. Well, if I have 6 y's upstairs and 1 down, then I've got 5 more upstairs than downstairs. If I have 2 x's upstairs and 9 downstairs, then I have 7 more downstairs. Okay, but what about this 2 cubed and this 5? Well, again, this is all related through multiplication, so I took care of that each base occurs only once, but I need to do this, which is 2 times 2 times 2 is 8, times 5 is 40. This 40 is on the bottom. These 2's and this 5 are on the bottom. They're going to stay on the bottom. So each base occurs only once. I've multiplied out any constants that I have and simplified that, and that is considered all the way simplified. Now, one last thing that I want to point out here is that if I have something like 2 over x, and this is being raised to the, say, negative 4th power, this is the same thing. Okay, so this is this rule right here. This is the same thing as saying, well, that's 2 to the negative 4th and x to the negative 4th, which is the same thing as, well, if this 2 is being naughty, or the negative 4, then I need to put that downstairs, and the 4 becomes positive. And if this x is being naughty, then it needs to go upstairs. And now it's being positive. This will be x to the 4th, and 2 to the 4th, or 2 times 2 times 2 times 2 is 16. Beautiful. Okay, well, some people are like, wow, that's crazy. You could also, I want to show you that you could just flip this. Watch this. What ends up happening here? This is negative and the exponent is negative on, and there's a quotient inside. You can just flip the whole dang thing, whatever's inside, and make it positive. And then remember that every one of these, a to the n, b to the n, belongs to this exponent. Well, look, x to the 4th, 2 to the 4th. Okay, so wait, what did I just say? Well, you can see that we can skip this step right here, because if I have a negative out here, they're just both going to end up flipping the opposites. So I might as well just flip them to begin with. Okay, so I could think of this as, if I have a over b, and this is raised to the negative n, I can just think of this as b to the n. Let's do it this way. B over a raised to the n, which will be b to the n, a to the n. And you can see that we get the same result. So I start with the same thing, but the process in the middle is different. So I can either distribute the negative here and then flip them both, or I can just flip the whole thing, make this positive, and then distribute them both. So you can, however you want to think of this is up to you. All right, so hopefully this is helpful, broken down into like these 3 steps and which rules go with each step. So if you have any other questions, please do let me know. And good luck on your exam.